Hello, everybody. Thank you for sticking around late in the afternoon on a Friday. I know it's been a long week. My name is Myk Melez, and I'm going to talk to you about offline web apps on GitHub Pages. First things first, this is my Octocat. She helps me to code. She pair programs with me by sitting on my lap and staring at me. Very helpful. But more importantly, I work for Mozilla. You may have heard of us. We make Firefox. And my team at Mozilla has lately been thinking about how do we demonstrate the promise of emerging web technologies to close the gap between the web platform and native platforms, not only mobile but also desktop. And so the idea that we've been kind of riffing on lately is, well, offline web apps are great. It would be great to have a really simple way to publish them and deploy them. GitHub Pages is a great way to publish and deploy websites. What if we mix those two things together? So GitHub Pages, how many people were here at Ben Balter's presentation yesterday? This room, same exact time? OK. So Ben talked about 10 ways that people are using or misusing GitHub Pages. I'm going to demonstrate an 11th way to misuse them. Definitely a misuse. So GitHub Pages are a really simple static hosting service for static websites. And it's really easy to publish to them. You just use a repository. You create a branch in your repository. So like I said, at Mozilla, we've been thinking about how do we make it really obvious that offline web apps are this great new way to make web apps feel a lot more native on a variety of platforms. And what I mean by offline web apps, this, by the way, it's not a solar outhouse. It's actually a solar dehydrator. It definitely is offline, though, and it's got a lot of juice. So I figured it was a reasonable metaphor for offline web apps. So what are they? Offline web apps are very simply web apps that run and that work when your network connection doesn't. And that's not necessarily to say that you're in airplane mode or you have no network connection at all. Sometimes you may be theoretically connected to a Wi-Fi network. But what you really have is something that my colleague Bill Walker calls Li-Fi, because your network status indicator says, hey, you've got a network, and then you try to load something and it just fails. So with offline web apps, that doesn't happen. Offline web apps just work. Let me show you an example of a web app that doesn't work. This is the thing that people often see today. You know, you try to load some website or some web app. This particular example is from Android, and it's Firefox on Android, but this happens on all browsers, on all platforms. You don't have a network connection, so you don't have a website. You can't load the web. It's particularly frustrating because in many cases, the browser has actually got a lot of the assets. If you've ever loaded this site before, the browser has a bunch of these assets in its cache, in some cache somewhere. But if it can't connect to the website, it doesn't know that those assets are up to date, and so this is what you get. The web is broken. By contrast, native apps just work. By default, if you've installed a native app, that means you've installed all of the assets that are required for that native app to function. And most native apps work whether or not you have a network connection. There are a few that will obviously show you more useful information when you have a network connection and they can synchronize data. And there are even a couple that just don't work at all and say, hey, I'm sorry. But for the most part, native apps just work. And we want web apps to work just as well as native apps do. So for the last few years, the answer to this question, how do you offline a web app, how do you make it just work, has been application cache. An app cache is a standard that was designed a few years back to be very simple, very focused on offlining, a declarative API. You point your web app at a manifest. The manifest lists all of the assets that your app needs. The browser downloads them, and then your app works offline. Sounds great, right? Unfortunately, after browser implementers implemented app cache, and web developers started using it, we realized that there were all sorts of edge cases that we hadn't considered, and problems with the specification. And foot guns, like if you happen to mistakenly cache your manifest for a long time, you could no longer update your web app. You were just stuck until your manifests expired. And if you set a really long time to live, then you're really screwed. In fact, it's so bad that Jake Archibald, who works on the Google Chrome team at Google, published a really long laundry list of everything that was wrong with app cache and said basically, you know, application cache is a douchebag. So web platform developers essentially started over from scratch. And what we did is we worked on something, and this is not just at Mozilla, it's at Mozilla, Google, Chrome developers are working on this, Opera as well, is we implemented something called service workers. And service workers is basically the anti-app cache. Everything that app cache is or isn't, service workers is. So app cache is a declarative interface. Service workers is an imperative interface. App cache focuses solely on the offlining case, and service workers is a more generic solution. It supports offlining, but not only offlining, it supports a variety of other use cases, and I'll talk only a very little bit about those a little while later in the presentation. But suffice to say, the two APIs could not be more different. So service workers are a very powerful abstraction. How many people here know what a web worker is? Okay, so that's a good maybe half of you. How many of you know what a JavaScript is? Okay, that's almost everybody. So a web worker is a JavaScript file that runs in a separate context from your web page. It runs in its own context, also in its own thread, and it's useful for spinning up basically a background process to do some kind of heavy-duty lifting without making your web page unresponsive. And a service worker is similar to a web worker in that it also runs in a separate context, in a separate thread. But unlike a web worker, it has a very defined cycle, life cycle for installation, activation, and update. So that you can, your web app can specify, this is my service worker. The browser can launch your service worker, know that it's downloaded all of the resources it needs to consider itself to be installed, activate your service worker, and then your service worker is now serving all of the files that your app needs out of a local cache. So what a service worker actually does, once it's installed, it can actually intercept all network requests that your application makes. And it does this transparently. Can y'all hear me? Okay, great. It sounded like my mic might have gone out there. It does this transparently so that your app can progressively degrade. If you add a service worker to your app to make it work offline, and then somebody runs your app in a browser that doesn't support service workers, that's okay. Your app will just work the way it works when it's online. So the thing that my team has been working on at Mozilla is a project called Offliner. And yes, it's pronounced Offliner, like Trough or Gough Street here in San Francisco, or Fish, according to an English writer a long time ago. And so what Offliner does is a few different things. One thing that it does is it creates a service worker for an app. So you tell it, offline my app, and it actually writes the service worker script. Obviously, you can do this yourself. The point of this tool is to try to make it super simple for you to offline your app and deploy it to GitHub Pages. So step one, offline your app. You point it at your assets. It generates a list of your assets and writes a service worker script that will offline all of them when a user loads your app. So that's number one. Number two, deployment. It's not that hard to deploy GitHub Pages, but we want to make it as simple as possible. And so what we've done with Offliner is added a command called deploy, which will check out a copy of your repository, push the files, including the service worker that the offline command created, to the GH Pages branch, commit the changes, and then push them up to GitHub. GitHub then takes over and actually automatically deploys your website to GitHub Pages. And then the last command we created and this is still kind of a work in progress. So it's great to be able to deploy locally, especially when you're the only guy working on a project. But most people are working on teams, and they have some kind of a flow. It might be the GitHub flow, or it might not be. But for a lot of people, it is, and that means that you're submitting pull requests, and other people are reviewing them, and then they might merge them into the master branch. And it would be really great if every time somebody merged a change into the master branch, you could automatically deploy that change to your GitHub Pages site. And so what the configuration tool in Offliner does is it goes through this sequence of steps to configure Travis CI to auto-deploy changes to your app whenever you push changes to the master branch. For those of you who don't know, I guess a lot of people do Travis CI. Anyone? Everyone? It's a continuous integration tool. What that means is that not just for web apps, but for any project, you can hook it up to GitHub so that anytime you check in changes to a branch, Travis will build your project, it'll run tests, and it can also deploy to a variety of hosting services. Notably, it can't deploy to GitHub Pages. But what it can do is it can run any arbitrary script after successfully building and testing your changes. So we can write a script that makes Travis auto-deploy to GitHub Pages. And that's what we've done. And if you Google online, you can find people who have documented the process of setting up auto-deploy manually. And it's straightforward. It's not that complicated, but it is a long process. You'll find that there's 10 or 12 steps. So the point here is to make it as simple as possible, to make it a single step to essentially say, OK, configure my repository, configure GitHub and Travis so that when I push to master, Travis will auto-deploy after building and testing directly to GitHub Pages. I'm not going to demonstrate that one today because it still has a few quirks and kinks to work out, but I will demo a few other things. And I'm going to juggle this microphone while I'm doing it, so that'll be interesting. So the first thing I'm going to demonstrate, I'm in a directory containing a project. I've already configured this to work with Offliner. The text you'll see is going to be bigger. I see a guy saying bigger, bigger. I can't make the tabs bigger. Apple has decided what size tabs I should have. So I can't do that, but I did make the text bigger, so hopefully that'll show up for you back there anyway. So I've already configured this to work with Offliner. I've already installed Offliner. It's a node module. In this case, I'm going to show you how to use it as a command line tool. So I've installed it globally, npm install-g Offliner. But you can also integrate it into a Gulp or a Grunt task runner if you want. We've actually used Gulp to build Offliner itself. So first to offline the set of assets, which I've already built into the dist directory of this app. And so what it does, it says it's caching. It's not completely accurate. It's not actually caching. It's more that it's writing a script that will do the caching on the client after a user loads the app. But in any case, you can see that it's cached all of the files in that dist directory. There are options if you want to specify that you only want it to cache a subset of files. You can do that as well. And then now if I want to deploy that, I call deploy. I point it at the directory again, which now includes the offline worker script. And that clones my repository again. I don't want to mess with your working directory. So I make another clone. Check out the site, check out the GH Pages branch. Replace the files with the new copies. Commit those changes, push them up to GitHub. GitHub does the rest. It deploys that GH Pages branch onto GitHub Pages. So I've actually done that with this app right now, offline web app. You know, one of the first rules of presenting is never live code. It's always a terrible idea. Something will go wrong. You should always just take a video of yourself doing it. But so far, that worked OK. But what does this actually mean? This app is just a kind of a throwaway app that I bootstrapped for the purpose of showing this process. But over here, I have this other app, Egg Timer. And it's a very simple app that counts down from some time you specify to 0. So if you want to know when your egg is finished boiling, for example, or you want to set it at the beginning of a presentation, if you remember to do so, you can do that. And if you don't, that's all right too. And so this is an offline web app. So I'm going to show you what that means. I'm going to go over to my network status indicator, and I'm going to turn Wi-Fi off. And for those of you in the front row, you can probably see this. Those of you in the back may have to take it on faith. This is a power cord. This is not an Ethernet connection. That's DVI. That is also not an Ethernet connection. I'm not going to pull that, or you won't see anything. Oh, and then this little thing right here, that's just a USB dongle that powers my clicker. So that is also not a network connection, I promise. Now I will press the reload button. Did you catch that? You probably didn't. For a couple of reasons, one of which is this is a very small app, so it reloads pretty quickly. Even when I'm reloading it over the network, it reloads pretty quickly. But in this case, I'm not. I'm reloading it from a service worker that is running on my machine, my laptop right here, serving files out of its own cache. And it's not just reload, by the way. I can close this tab, and I can reopen it. And I get the app back. And I mean, in fact, I can close my browser. Close tab, close browser. Reopen tab, reopen browser. The app comes back. In a way, you think, well, OK, sure. But this doesn't happen on the web today. Today, what you get is web page broken, cannot load, no network connection. Most web apps should work like this. Most web apps should just come back, just like all native apps just start and run when you start them. By the way, this also works in Chrome, and Chrome's developer tools have this handy feature that, unfortunately, we don't have yet in Firefox, which is that if I actually reload this app after opening the tools, this also might be a little bit difficult for folks in the back to see. But the developer tools say from service worker to indicate that these files were actually served out of the service worker cache. So that's another way. In Chrome, you can see that they're really doing what you think they're doing. And we'll get that in Firefox soon, I hope, as well. By the way, you can also work around the service worker cache. If you really don't want service worker to serve your files for a particular load, let's say you're developing and you want to make sure that the files that you push to the server are really there, force refresh, force reload, Shift, Command, or Control R will bypass the service worker so that you can see what's actually. So if I do it right now, remember I have no network, so it can't connect to the internet, so I get the fail dyno, I guess. Okay, so there are a few caveats to be aware of. First of all, HTTPS is required. And the reason for this is that service workers are code that runs on a user's browser whether or not that page that they originally loaded, that registered the service worker, is running. They can run in the background, even if the user has closed that page down. They can say, wake me up. A couple of things that I mentioned earlier I was going to talk about later. Service workers is a more generic solution for a variety of problems. Offlining is one of them. The other is periodic background sync. And another is we're also working on building web push on top of service workers so that websites can let users know when something has happened that they think they want to know about, like on Facebook, that somebody's dog looks cute. So because service workers can run in the background, that's a very powerful privilege, and we want to make sure that it is as hard as possible for a bad actor to exploit it via a man-in-the-middle attack. So HTTPS required. It's not required if you're a developer on localhost. Then we relax that restriction so you can actually build your service workers locally and test them. It's also very helpful for any web services that you use that you're not hosting on the same origin, i.e. domain, to use CORS headers. CORS stands for Cross-Origin Resource Sharing. It's a way for a server to say, it's OK for web apps from other domains to access the services that I'm providing, the resources that I'm serving, or the API endpoints that I expose. And in the same way that XML HTTP request is limited to same origin requests unless you jump through a few hoops, or if a server publishes CORS headers, service workers has that same kind of great power and great responsibility. So there are limitations. It's not that you absolutely can't load a resource in a service worker from another domain, but you're limited in your ability to do so. GitHub's API, for example, all publishes CORS headers. I think Travis's API all publishes CORS headers. Enlightened web services will do this. So you can write an offline web app, for example, that is in a GitHub client, or a Travis client, for that matter. So the last caveat is that all of this work is in progress. It's not quite done yet. Can I use service workers tells you some information that is mostly up to date, except for in the case of Firefox, which I'm going to work to fix, because as you can see from this screenshot that I took yesterday, can I use things that service workers are not available or won't be available in the upcoming 42, 43, and 44 releases, and we're actually planning to enable them in either 43 or 44. They already work in nightly builds, in developer edition builds. I don't think they work on beta, but I'm not 100% sure of that. Definitely nightly, which is 44, and developer edition is 43. And we plan to ship them in one of those two releases, depending on how all the work falls into place. They already work in Chrome and Opera, Chrome for Android. And by the way, Firefox for Android, same as Firefox for desktop, 43 or 44. So we're targeting service workers for both, for basically all of the platforms that Firefox for desktop or Android supports in the 43 or 44 timeframe. Actually, if you want to find out the status of service workers, an even better website is Jake Archibald's Is a Service Worker Ready?, which is kind of like Can I Use?, but specific to service workers rather than being kind of about the web in general. And he goes through, in a great bit of detail, the status of service workers on all of the various browsers and is completely up to date on that. So that's what I actually recommend if you want to find out about status. And the last thing I just want to say is stay tuned. Obviously, like I said, we're at Mozilla, we're planning to ship service workers in 43 or 44. We're looking at web push maybe for 45. There's a lot of things you can do with service workers that are really cool besides offlining. I think offlining itself is like hugely important, and it's going to make web apps work a hell of a lot better, but there's a lot more you can do with service workers, so stay tuned for that. And by the way, this presentation is a offline web app hosted on GitHub Pages. Thanks. Even though I didn't start my timer on time, I did just look at the clock, so I know that I have a few more minutes. If anybody has questions, I'm happy to take them. Yeah, so the question is, does this work for mobile, Safari, Chrome, iOS, Android? So Safari, I think the answer is no. Chrome for Android, yes, as well as the non-Chrome browser for Android. It will work on Firefox for Android. So I don't have a good sense of the story for Safari and for iOS. Generally, I don't actually know. Bill, my colleague, and Brendan, my other colleague, are both here, and they may happen to know something, but they're not looking positive about that. So I'm going to say I have no idea about iOS. But for sure, Android from both Google itself and Firefox's browser for Android are going to support service workers, or do already. Yeah, so that's a great question. So the question is, how do service workers solve the problem of stale data, which confronted us with app cache? So the service worker specification specifies that service workers have this basically an update. They have a life cycle, and the browser has to check the status of a service worker on the server periodically. In fact, I think if you say that a service worker's like time to live is greater than a day, then the browser will just ignore that and check it at least once per day anyway. And it does a byte-by-byte comparison, so it ignores whatever the server says and actually downloads the service worker itself. If it's any different from the service worker that it has, then it goes through a process whereby it installs the service worker, it lets the service worker get to a point where it says, okay, I'm ready to activate, I've done any, say, caching I need to do. If the page that is being controlled by the service worker is actually currently loaded, then the browser will wait until the user unloads that page to activate the new service worker, to deactivate the old service worker. Or the new service worker can say, screw that, let me take control, I'm ready to go. So service worker supports the kind of silent update model where like a user never knows that their application is periodically being updated. It also supports a more explicit model where the service worker can say, hey, I'm ready to update this app, and send a message back to the app. The app can then say to the user, hey, reload me to get the latest stuff. Or it can just do it automatically. I don't recommend it, but that's possible to do. So that, does that answer your question? Okay. I'm going to call on the guy back there and then you second. Can you? So can it cache the state of the application? So a service worker can cache arbitrary data, and so yes. I'm not sure that it necessarily makes sense. It could make more sense for the app to do that itself. For example, that egg timer app uses local storage because it has very little. It has very little state. If you had a bunch of data, you might say want to use IndexedDB. And I think the service worker has access to IndexedDB as well as its cache API that it uses to cache static assets. So you could certainly cache data in the service worker, but whether or not that makes more sense than having the application cache it itself, that's a good question. And then you had a question. Yes. Yeah, sure. So the question is, a little while ago I showed you, well, I can bypass the service worker cache by doing a hard refresh. I did that in Chrome, and that obviously broke my egg timer app. So what if I now do a soft refresh? What will happen there? And what will happen is that the app will come right back. Because when I do a soft refresh, the browser says, OK, hey, there's a service worker active for this app. And so I'll go ask the service worker to load the resources. So it unbreaks. Yes? Yeah, so the question is the specification flexible for handling multiple workers and making sure that they don't step on each other's toes, essentially? That's a great question. I don't have a really good answer for that, to be honest with you. The specification defines a life cycle by which a service worker, a new service worker, can kind of take over for an old one. But if somehow you manage to get two service workers to activate at the same time, I'm not sure what would happen. It's a good question, and I don't know if the spec covers that. I would have to dig in deeper. Any other questions? OK, well, thanks, everybody. I really appreciate it.